for example 1, we need to know the arc length equation first. So up on the box on the top, arc length says if theta is the central angle in a circle of radius r, then the length of the intercepted arc s is given by s equals r times theta. And the important thing here is where theta is measured in radians. So we want to make sure you highlight that. That's a very important part. Our theta, our angle, has to be in radians in order for this equation to work. So what's happening is we have our angle here that's rotating, and we're looking to find this arc length here. If we take a look at example 1, we want to find the arc length of the intercepted arc in each circle with the given central angle and radius, round to the nearest tenth. So here's what we're trying to find. In letter A, we are looking for this arc length, which is S. And we're given the angle, which is pi over 4, and the radius, which is 5 centimeters. So we're going to use our formula that S equals R times theta, and we have to remember theta has to be in radians, which it is. Right now we have pi over 4, which is radians. So we can just plug everything in. So this is equal to R, which is 5, times pi over 4. You're just going to plug that into your calculator, and when you plug that in, you should get about 3.9 centimeters. Please use the actual pi button on your calculator and not 3.14. So go ahead and try that. Make sure you get the right answer before you move on to letter B. Pause it if you need to. In letter B, we're given 60 degrees and 2 inches for our circle. So we're trying to find this length of our circle right here, given the inner angle is 60 degrees and the radius is 2 inches. The problem is, though, that our angle right now is in degrees, and we need to change this to radians. So before we can use our formula, we need that to be in radians. So we're going to take our 60 degrees, and from the other day, to change it to radians, we are going to multiply by pi over 180 degrees. And when we multiply 60 pi over 180 and simplify that, you should end up with pi over 3. Now we can use that in our formula. So we get S equal to 2, which is our radius, times our theta in radians, which is pi over 3. And plugging that in our calculator, we should get our arc length to be about 2.1 inches. Then I'd like you to go do the other two, so try the 2 on the bottom here. So pause it now and unpause it when you're ready to check. If you did letter A correctly, you should have gotten about 4.2 meters. And if you did letter B correctly, you should have had about 1.2 feet. Let me know if you have any questions.